Okay, so what's a Y-intercept?
Good job.
Nick.
I'm sorry.
Fired.
Get your act together.
I just committed vandalism. I'm sorry.
No break. Alright. What's a Y-intercept? It's where it crosses the Y-axis. What is the x-coordinate for this Y-intercept right here? 0. The x-coordinate for any Y-intercept is always 0. So one way you can find, we kind of did this before, one way you can find a Y-intercept is plug in 0 for x. If it's on the picture, you can just look at the picture, but if you have some function and you want to find its Y-intercept, you can just plug in 0 right there. Basically, this would be -5 for the Y-intercept, but because the Y-intercept always has an x value of 0. Okay, what are these thingies? X-intercepts. What is the Y value of the, what is the Y value of the X-intercept? 0. So, if you want to find the X-intercept, you can turn the Y into 0, or in this case, the f of x. F of x and y are kind of interchangeable, right? Like this could be the y-axis or the f of x axis. So, if you make that 0, that would help you find the x-intercept. X-intercepts are also called, so this might be like 4, 0 or something, I'm just making it up. X-intercepts are also called the zeros of the function, because it's what makes the function equal 0. Okay, so if they say find the 0 of the function, it means find the x-intercept, or in other words, find what x values would make this function equal 0. Now we've solved these before. How did we solve these before? Last chapter. Factoring or
Quadratic
formula. This one doesn't factor, so you'd have to use quadratic, but yeah. Does that make sense? Is that clear? So if you want to find the y-intercept, you put in 0 for x, just plug in the zeros. And that would be like -5, right? For this function, that would be 0, -5 would be the y-intercept for that function. If you want to find the x-intercept, you make the function equal to 0 and solve by factoring for quadratic formula. It's called the zeros of the function also. All right, now we're ready to move. Okie dokie. On number 1, state the y-intercept and zeros, x-intercepts, of each function from its graph. If there is no real zeros, state so. Okay, what is the y-intercept on number 1?
0, 6.
0, 6. Yeah, let's write it. Sometimes you can just say 6, but let's be a little more detailed. Let's say 0, 6. I'm basically going to copy out of the book, wrote the answer. Anyway, what are the zeros of the function? Where does the function value equal to 0? Where does it cross the x-axis at? -4 and 6. So what I'm going to do for that is just put x equals -4 and 6. That's where the function is equal to 0. It is also the x-intercept, but -4 and 6. Okay, number 2, where's the y-intercept, or 3, where's the y-intercept? 2 up, so 0, 2. And, what's the zeros of the function?
There is none.
None. Does not cross the x-axis. If you set that function equal to 0 and tried to solve it, it would give you 2 imaginary answers. Okay, that means there are no zeros of the function. Anyways. Number 4 does have a 0, by the way. So, okay, number 5, find the zeros algebraically. What does that mean? Okay, set the function equal to 0 and solve. You guys know what the easiest way to solve 5 is?
Factor.
Factoring. Because what two things multiply into negative 14?
Negative 7, positive 2.
Negative 7 and positive 2. And what x values would that be?
7 and negative
7 and negative 2. So, if you find these, like the X-intercepts and the Y-intercepts, that can help you get a really quick sketch of a graph. If we found the Y-intercept, that can help us. Number 7, negative 3x squared. So I'm just going to set it equal to 0 to find the zeros of the function. What x values make this 0? Does it factor? Do you guys remember the discriminant? If that comes out like it actually has a square root, that means it does factor. If you're not, if it looks hard, I don't know if you guys are, you might just go ahead and do the quadratic formula. Based on the tests, we haven't quite mastered that yet though, so I'm not sure that would be helpful or not. Some of us, did well, but a lot of us screwed this part up right here. Probably most of us even got this part wrong. I think the problem though was basically we were putting the wrong A, B's, and C's in. I think that was most people got it wrong, did that? Because when you subtract it to the other side, we weren't doing it right. I don't know. This one, the A, B, and C, it's kind of obvious though. Negative 3, 5, and 2. Okay. This does factor. Okay, I'm just going to factor it. I don't want my first term to be negative though, so I'm going to multiply everything by negative 1. That'll make it easier to factor. So what goes on the front of the parentheses? What goes into 3x squared?
3x and x.
Okay, and then what goes into negative 2 for the back? Negative 1, 2, or negative 2 and 1. I want, when I FOIL it, I want the outside inside to give me negative 5. If I put the negative 2 out here, that gives me negative 6. And the plus 1 right here gives me negative 6 plus 1, negative 5. That's right. Okay. And then let's go to 16 today. Okay, do you guys remember what the answers were for this? Negative 1/3, positive 2. Okay, on 9, what multiplies into 8 that adds up to negative 1? What multiplies into 8 that adds up to negative 1? The only thing that goes into 8 is 4 and 2. Does that add up to negative 1? No. Or 1 and 8, is that up to negative 1? No. So if it doesn't factor, what? Quadratic formula. All right. Let's give it a go.
So
plus or minus square root of b squared. Negative 1 squared is positive 1 minus 4ac over 2a. Okay, here's the thing. Under the square root, I get negative 31. So what kind of answer is that?
Imaginary.
Imaginary. If there's an imaginary answer, what are the zeros? They-
Real.
They don't exist. Okay, so on this one, we can just say it doesn't exist. What do they put? No real zero. Okay, we'll just write that. No real zero. So the graph of this thing would be like floating above the line, basically. It would not touch the x-axis. Maybe we should have done the discriminant first, and that way that would have been a little bit less work. Number 11. Okay, so it's x plus 1 squared minus 16. How could I solve that? How would I figure out what x plus 1 squared is?
Square root?
Well,
No.
you'd have to square root the whole side, you can't just square root one thing. X plus 1 times x plus 1, it's like a FOIL problem. So I could do x plus 1 times x plus 1, FOIL that out, and then subtract 16, and then it would look like the other problems. There's actually an easier way to do these though. Like we could FOIL that out and put in the minus 16. It would look like the others. Okay. You can kind of do what Nick said. You can get the square thing by itself on one side. I think this was on one of the assignments last chapter, but it was like towards the end and we didn't go that far. And you don't have to solve it this way. And then since the whole left side is squared, I can take the square root to get rid of the square. Here's another thing most people got wrong on the test. When I do the square root trick, it's not just square root of 16, you don't just put 4, it's positive or negative 4. Because a negative squared is also 16. Negative 4 squared is also 16. Anyways. You guys see what I did there?
Yeah.
I square rooted to get rid of the square, so it's just x plus 1. And this became a 4, positive or negative. And how would I solve this for x? Let's get x by itself.
It's 3 and negative 5.
So it would be subtract the 1, so it would be negative 1 plus or minus 4, or plus or minus 4 minus 1. So what's negative 1 plus 4? 3. And what's negative 1 minus 4?
Negative 5.
Probably the easiest way to do that problem. Twelve is the same thing. So, 12 is harder. 12 is, alright, I'm gonna have mercy. We probably should do another one of those anyway. 12, it might have been easier to just FOIL out the x minus 1, but we're gonna do it the other way. So just like the last problem, I'm going to get x minus 1 squared by itself. How do I get x minus 1 squared by itself? What should I do first?
Dividing 2.
Minus.
is
Plus 5.
plus.
Plus 5. It's kind of like 2x minus 5, right? So you would add 5 divided by 2. So, yeah, add 5.
2.5.
Divide by 2. This is the point, once you get the square by itself, you square root it to get rid of the square. So that kind of cancels out with that. What's the square root of 5 halves?
10/2.
Yeah, this would be a good time for some calculator assistance. Basically, you're not supposed to leave square root of 2 on the bottom. You multiply top and bottom by square root of 2. Okay, but I did something wrong.
Plus or minus.
Plus or minus.
Ding, ding, ding.
Good job,
And I still haven't quite solved for x. What else should I do?
Add the 1 now.
Add the 1. So it's x equals 1 plus or minus square root of 10 over 2. Which, since that doesn't simplify, you can leave it like that. I don't know if both leave it like that or they change it to one fraction. We could, yeah, we could change 1 into 1 over 1, which is 2 over 2. Alright, it's okay to leave it like this. That's probably a better answer than what I'm going to write. If you have a common denominator, you can actually put 1 becomes 1 over 1 or 2 over 2, so you could actually put those together. I just want you guys to see this. 2 plus or minus square root of 10 over 2. That's another way. I think this way we had it at first is probably a little simpler. Right there. But these are the same thing. Okay, 13 is graphing. All right. Time for some graph paper. Yeah, 16 might be a good place to stop. Maybe.
Stop like this. Well.
No. I was thinking going past 16. That was my better option.
Hatred for us.
What?
Money.
What fuels your hatred for us?
Oh, there's a list.
Does it start with A?
Wow, everybody has the same.
Is it the racism? Come on.
I was going to start listing people's names.
It would just be one
Need
name.
graph paper?
Funny kid.
Did we graph yesterday? Yeah, we did.
Yeah, we did.
And it was
Here's one for yesterday.
Not anymore.
For today, yeah.
No. Yeah, we got
Spaghetti inside, you know? Bungee jump. Yeah, that was a good one. That was pretty good. That was creative. That was creative.
That should be you. Can't say stuff like that to me.
Broke it.
Okay,
Screwed it up. Folks.
Yeah.
Need to go back and fix that. Alright. X squared minus 2. How do we graph this? So this is kind of a review of yesterday. A lot of it does say greater than, so that is new. But it's going to be pretty similar to yesterday. same method as yesterday. Where would the vertex be for number 13? You guys remember this stuff? Yeah, it's down to, yeah. That's kind of what we talked about yesterday. Left one, right one, up one, down one. So this would be down 2. So 0, -2 is the vertex. That's the center of my graph right there. Okay, then I said yesterday, let's choose a couple x values that are close to the vertex. If I choose like x equals 10, that's going to be like way up there on the graph because parabolas are really steep. So it's going to be like through the roof. So I want to choose x values close to my vertex,
1.
like 1 and 2, or -1 and -2. The vertex is at 0, so 1 and 2 are very close to that. So if I plug in 1, what do I get?
-1.
-1. If I plug in 2, 2 squared minus 2, is 2, and then you graph those 2 points, 1, -1, 2, 2. If you did it right, it should look like half a parabola. And I don't really need to plug in -1 or -2 because I'm just going to kind of cheat and do the mirror image. Okay, but something's different on this problem from yesterday.
We need a dotted line and shade.
It's greater than. You guys can probably guess without me telling you what we have to do. Yes, it's a dotted line. So something like this. Because it's greater than, not equals to.
Straight inside parabola.
Yeah, if it's y is greater than, you're supposed to go above. So above is kind of like inside in this case. Like if it's a bucket, you know, it's above the bucket, inside the bucket. So it looks like that. Think you guys are done? Maybe? 15? Last one for today. Can you guys tell me before I graph, what is that 1/2 going to do to the graph?
It's gonna make it go.
Upside down. Oh, wait.
Flatter. It's going to go up half as fast as normal. It is going up because it's a positive 1/2, but it's going to go up slow. So 16 is going to go down because there's a negative in front quickly because it's a 3. So you might want to make room for 16 like well below the graph.
You know what else is it for you?
Anyways, y is greater than 1/2 x minus
No, get out of here.
2 squared minus 1. Alright, where is the vertex going to be?
It's gonna be to the left. No. Right 2.
Right 2
Down 1.
and down 1. So it's at 2, -1. I'll put that in my table. 2, -1. That's going to be the middle of my graph right there. Alright.
Negative. No. Just 1 and 0.
1 and 0, those are close to the vertex, right? Right there. Could have been 3 and 4. That would have worked also. Okay, if I plug in 1, you get 1 minus 2, -1. Notice I'm using order of operations here. I'm doing parentheses, exponent, multiply, subtract. That's the order. 1 minus 2 is -1, squared is +1, times 1/2 is 1/2, 1/2 minus 1 is -1/2. You could just plug that all in your calculator. Just put a 1 right there and plug all that in. That would work. If I plug in a 0, 0 minus 2 is -2. squared
-4.
is positive 4. Negative 2 times negative 2 is positive 4 times a half. 2 minus 1.
1.
So I'm graphing 1, negative a half, and 0, 1. And then the twin image. So it's a little bit broader. Kind of dot,
Wait. Is it
kind of missed.
spelled?
Oh, yeah, sorry. Jordan caught me.
I didn't know if ours is spelled, but.
No, that was me that time. All right, I forgot we're doing a grading then.
Wait,
So-
no, let me see.
It's just like the last time, we're supposed to make this a dotted line. That's too steep. Okay, it's greater than again, so it's gonna be above again. If it was less than, you'd have to color a lot more, all below that thing.
Can you stop and come to work here?
Beautiful.
You seen that video? I'm not gonna. You seen Monkey?
Donkey.
Oh.
That was the Shrek version of Donkey.
Are you done? Can I finish that happy?
I think you're done. Throwing your trash in for you in the class. I'm gonna break you.
You gonna break me?
Yes.
Oh,
Like a
I should-
toothpick.
We don't have to make threats to me.
Yeah, whoops. Should have stopped recording.